Is it on?
Yeah.
Can you see me in the screen? Great. So we're going on to talk about microprocessors, and I have the guide for the 8-bit AVR microcontroller. This is the Atmel 328P, and Edith turned on the screen. My name's Evan Williams, by the way, and I'd like to look on with a magnifying lens on the chip to see if we actually have the right chip before we go too far. So I do that. It says new IDE, Arduino.org. That's going to be our first lab, is to download the IDE so we can all program this chip. But this is a microcontroller. What's the difference between a microprocessor and a microcontroller?
You talking to me?
Yeah.
Well, I think you have to process it first and then you control it.
Yeah, a microprocessor is like a general computer for processing, and there's a lot of processing you can do. You can do number crunching, you can do data analytics, you can do your balance your checkbook on a microprocessor. That's what we all started with, those of us who had IBM PCs and Apple Macintoshes. This is a microcontroller. It's used for turning on lights and turning them off again. I can't even see on this with this magnifying lens. I can just barely see what this says here. So we'll have to believe that it's the right data sheet, but we're going right to the data sheets. It's all 452 pages, and I'd like to talk about the fact that because this is a microcontroller, the chip inside of it has a different architecture than a microprocessor. If you scroll down, Ida, please, we can get to the guide. So maybe use the down arrow. Oh, good, you did it. Keep going. Oh well. Or use the mouse. If you can use the mouse and get over to this area over here, we can look at a 4 AVR CPR core. Try to go over to 4 right here. Well, nice try anyway. The AVR microprocessor or microcontroller, there's a diagram in there that would be very helpful, but we'll get better at this. Has a keep trying to scroll up till you find the diagram. The scroll the page up and page down are over there. The microcontrollers use a RISC architecture, reduced instruction set computing architecture. The older computers that we had used complex instruction sets. This is very important because it means that the chip can react very fast to stimuli and signals. And that's what we have here. We're going to be wiring up circuits, as I mentioned, and we want to, did you find the diagram yet? Okay. Oh, good. Keep going. You're almost there. These are the details about the architecture and all the registers within it. And they work differently than the old computers did. It matters somewhat. Also, it's Harvard architecture versus von Neumann from Princeton. So von Neumann was, here it is. Stop, stop, stop. That's it. Great. In this diagram, we can see that the computer has an arithmetic logic unit. That's the heart of every computer. But it's different than the old computers because in the old computers, the program and the data was on the same bus. In this computer and all the Harvard architecture computers, and I believe although I don't know this for sure, that Harvard architecture is used to make reduced instruction sets work fast. The data is on a separate bus, and the program is in the flash. There's 32 kilobytes of flash memory. And when we load up the program for our first experiment, which is going to be Blink, we're going to load up that program. The program counter then says, okay, let's go through, run the program, and do what we need to do with the data. Ida, if you press Alt-Tab, you should get to some of my other slide. Now that's Alt-Tab. Hold down the Alt key. Alt. It says 1, 2, 3, and from the bottom, Alt, and press Tab. and let go. You know, press and hold it. One more. Do it again.
Something burning?
Oh, that's the tape. Hold on, please. We'll be back.